Hello, my name is Alya and I am from Advisory J. In this video, I will be talking about my Physics 1 final project. Starting off, the big question is, why do visionary leaders adapt? Project-focused question is, how can humans analyze transformation based on physics concepts and law in day-to-day life activities? The outcomes related to this project is to be able to develop a forward-thinking design based on the understanding of Newton's law of motion, and being able to analyze a daily life problem based on the principle of work, energy, and power. Starting off, this first image shows a subject leaning their body weight against their arm on a table. The physics concepts that can be seen in this image is normal force, mass, gravitational force, and applied force. If this picture shows me leaning my weight towards my hand and resting it on the table, then I will be able to analyze the different forces and the first and third Newton's law. The illustration above shows the arm that is leaning on the table is pushing down on the table. This is gravitational force and mass. It can be seen that the table is not caving in. This is because it is exerting the same amount of force towards my arm. This is called normal force. Newton's first law is often called the law of inertia. As we know, some objects have more inertia than others. It can be known that the table in this image is considered as the said object. As I said before, this image also shows the third law. Since I am leaning and putting pressure against the table is also exerting the same amount of force towards my arm. The second photo shows a subject being pushed on a swing. The physics concepts that can be seen is normal force, mass, gravitational force, applied force, tension force, and law of conservation energy. The hypothesis of the situation is, if the picture shows me being pushed on a swing hanging off of a tree branch, I am able to see the tension force, applied force, and law of conservation energy. It can also be seen that a lot is going on in this illustration. Tension can be seen in the rope holding me up on a tree branch. Gravity is pulling me down against the tree branch, and the tree branch is pulling up to be able to sustain my weight, thus causing tension. Calculations for the potential energy, kinetic energy, and mechanical energy. Starting off, the mass, or my weight as a child, was 30 kilograms, and I was being pushed 3 meters per second with a gravitational pull of 10 meters per second square and the height of 5 meters. Potential energy is mass multiplied by gravity multiplied by height, which is 30 multiplied by 10 and 5, which equals to 1,500 joules. For the kinetic energy, it is half of mass multiplied by velocity squared, which equals to 135 joules. For the mechanical energy, it is the potential energy added by the kinetic energy, which is 1,500 added by 135 to 1,635 joules. This is the law of conservation energy. Conservation energy happens when an object is at rest. This would mean that the velocity would be zero. Starting off, mechanical energy A would equal to mechanical energy B, which means potential energy A plus kinetic energy A equals to potential energy B plus kinetic energy B. Translated into the numbers, this would mean 1,500 plus 0 equals to 0 plus keV. Kinetic energy B would equal to 1,500. Half of mass multiplied by velocity squared would equal to 1,500, which means that velocity squared is 100 and the velocity would be 10 meters per second square. The situation in this picture portrays the action of a subject pushing another party on a swing. This shows Newton's second law, describing that a force applied to an object at rest causes it to accelerate in the direction of the force. The third image shows the subject leaning against a ladder. The physics concepts that can be seen in this picture is tension, normal force, and mass. The hypothesis is, if the picture shows me hanging on a ladder and leaning back, then I will be able to analyze the concept of tension and Newton's third law. Newton's third law states that there is an equal and opposite answer to any action, force, in existence. This can be seen in the image as I am leaning back, the ladder is also pulling against me with the same force, causing me not to fall. Answer the big question of why do visionary leaders adapt? A leader is someone who can hold responsibilities. People who can look ahead and exceed the sight of others are visionary. Visionary leaders can establish good relationships with various parties so that they can build trust and, more importantly, direct the ego and interest of individuals and groups to realize the vision of the organization. A visionary leader must be able to adapt to current and future situations to be able to create a long-term sustainable plan. Answer the focus question of how can humans analyze transformation based on physics concepts and law in day-to-day life activities? Physics concepts help humans analyze and predict future outcomes and paths of a specific action. By being able to calculate these said energies, humans can predict what will happen if an action is followed out in a specific situation. That is all. Thank you for listening and watching my video.